Hi, my name is Wendy, and I'm going to be talking about memory and how it relates to motor behavior and how we are able to move. The first one is encoding, which is basically the process of transforming information into a form that can be stored, whether that's in long-term memory, short-term memory. Another thing I want to talk about is storage, which is the process of placing the information into your long-term memory. It goes for your short-term, then you encode it, and then it goes into the long-term memory. Another thing that's important to know is rehearsal, which is just basically a process. It's like practicing. It's a process that enables the transfer of information into your long-term memory from your working memory. It allows the brain to hold and process the information briefly before determining whether it's important or relevant enough to be stored into the long-term memory or transferred into the short-term memory. If you hear like a sound or maybe somebody's voice or music coming from somewhere, it can briefly just stay in that sensory memory before you're going to decide if you want to store that or if you're just going to forget it immediately. The memories that we have in the short-term sensory store, they are very quickly susceptible to be able to fade. This is why sometimes in court cases, the witnesses can't always recall all the information. This is the memory that has a limited capacity. It's usually able to only hold around 5 to 9 items or chunks of information at a time. The memories in short-term memory tend to fade relatively quickly if they aren't rehearsed or actively maintained. It's also very vulnerable to interference. This is also where encoding comes to play in. Information in the short-term memory is primarily encoded to the long-term memory based on the sound or the meaning of the information. One example of short-term memory would be the fish Dory from Finding Nemo. She doesn't have that very good of the long-term memory going on. Like short-term memory, the working memory has a limited capacity and it usually only holds around 5 to 9 items of information at a time. Its capacity can be expanded if you rehearse. Working memory also holds information for short periods of time. It is also actively involved in processing information and manipulating information. This includes things like mentally rehearsing information to be able to store it for longer, or organizing information into different structures and integrating it with the knowledge that you already have. The working memory is kind of known as the memory that you use to plan and carry out behaviors in your motor functions. And it's connected to the short-term memory because it stores information from the short-term sensory store for processing, and it also helps with the retrieval of information from the long-term memory for processing and integration with the short-term sensory store as well. The last form of memory I want to talk about is the long-term memory. Following practice or rehearsal for permanent storage of information, it has a much larger storage capacity compared to working memory and short-term memory. It also provides motor pattern retention for retrieval. And the more you rehearse information, the stronger that information will be in the long-term memory. Things that you do that require long-term memory could include swimming or riding a bike. An example of long-term memory would be, if you inside out, there is the long-term memory, which is where all of Riley's memories are stored, and all of our memories are stored there. It's a very large capacity. There's a great study that I read about working memory. It's called Prioritized Verbal Working Memory Content Biases Ongoing Action. The idea of the study is to test the link between working memory and action control. In the abstract of this article, they say, "We test the idea that such everyday cognitive slips emerge from the typical adaptive processes by which working memory guides behavior." This is like when you're texting a friend and you're also having a conversation with somebody else in the room and you can't quite focus on one or the other. You just accidentally text the wrong thing to the person, or you'll say the wrong thing out loud, and it's like you're mixing up the two. This is when working memory can bias a certain action that you're doing at one time. So the first experiment that they did in this study is the participants were asked to remember a certain directional word, up, down, left, right. They had to remember that word while they were also performing a mouse clicking activity that was based on a visual cue in front of them. The experiment manipulated the predictability of the working memory relevant to the motor task and the priority of the individual's working memory. But when the remembered word conflicted with the mouse activity, the participants were more likely to click on the wrong target or say the wrong word. The movements were slower and less less accurate when the remembered word wasn't connected to the motor task at all. Movements took a lot longer when the working memory content conflicted with the motor task. Overall, in the study, it was found that working memory representations affect ongoing motor behavior. Researchers manipulated task relevance of working behavior to the motor goals. Movements were less accurate, less precise, slower, initiated later when they were incompatible with the working memory content. The question I would like to ask this class at the end of this video is, how are working memory and short-term memory alike, and how are they different?